Here is the electromagnetic spectrum again, going from radio, microwaves, infrared, visible, ultraviolet, X-ray through to gamma rays, where the wavelength gets shorter as you go towards the right and the frequency gets higher as you go towards the right. We're going to look at three parts of this spectrum, three bits that we label, and we're going to look at them and see what their benefits are and how we use them. So let's start off with this picture. What's the guy got underneath the bag? If we wanted to know without touching or without asking him, we could see what type of light is being given off by whatever's underneath that bag, or we could shine different types of light on it. If we tried X-rays, that would reveal it, but that would be quite dangerous. There is another way, and that is to see what infrared is being given off. We can see it is the guy's hand. Infrared is heat, and it's given off by every atom. It's given off by any matter. The colder something is, the less infrared is coming off it, but for a human body, quite a lot of heat is being given off as light, but as infrared light. This is me in under an infrared camera in Eureka in Halifax. So you can see my hands are red. When I touch my coat, I heated up part of the coat. Can you see that? And it left behind a bit of a glow. The phone is glowing red. That's quite hot that I'm filming with. But look at the little symbol on the back. Then let's have a look at ultraviolet. Ultraviolet, much shorter wavelength, and not quite as safe as the other things to the left of visible light. Ultraviolet light comes from the sun, and we're going to talk about that. Ultraviolet light will cause death of skin cells, and when it damages them, you get what we call a tan. But it can also damage the DNA inside those cells, and that will cause cancer. So we can prevent this by using sun cream. So have a look at the clip that's listed in the document and tell me, how does sun cream stop ultraviolet radiation from burning your skin? So the next question is, why do people sunbathe? Can you give the benefits and the dangers? There is a way that ultraviolet from the sun is protected, can be protected from us. Not just sunglasses, not just sun cream, but also the ozone layer, which you must have heard about, which is oxygen that is high up on the outside of the atmosphere, but it's bonded together, not O2 with two oxygen molecules, but three, O3. It's actually toxic if you were to breathe ozone in, but when it's up there at the top of the atmosphere, it stops most of the ultraviolet from coming down to Earth. But many years ago, chlorofluorocarbons, which are chemicals that were used in fridges and plastics and aerosols, they would drift up from wherever they've been used and float up to the top of the ozone layer and destroy it. And we found that there was a hole is starting to form in parts of the ozone layer. So here's the ultraviolet shining down. So 3 bands, the most dangerous, is prevented, but ultraviolet A does get through. But with a hole in the ozone layer, then we've got a problem, because we're going to get increased rates of cancer. So here's some data over 30 years. You probably can't see the years in quite detail there, but you can see that that purpley hole gets bigger and bigger and bigger and bigger. But since CFCs were banned and not used, this is one of the success stories, that the ozone hole is closing up. So the next question is, when were CFCs banned? And has the ozone hole closed up a little bit since that ban, or has it got bigger? Or has it completely gone? So you're going to find out. So here's data where you can see the year. So 1979 when it was first seen, and then in the 30 years since, you can see that hole getting bigger. Let's return to microwaves, which we talked about last week, and a few extra pieces of information that you're going to write and tell me about. So microwaves are used in airport scanners at certain airports, like in Manchester. And the picture quality that they can get from them is better than this picture, but this is the only picture I can probably dare show you. So airport security can see you naked. The microwaves will shine through your clothes, but not your skin, and not through any guns or knives that you might be hiding in your clothing, as in this picture. What do we think about that? What do you think about the idea of people seeing through your clothes? And there was a case a few years ago when the disc with all the images that had been recorded in a day was leaked online. Not very nice. And the guy did go to prison. But are microwaves dangerous? So we know we use them in ovens, we know we use them in communications, and we've just talked about we use them in scanning at airports. But is it dangerous? Look at that mass that's on the right, and can you see the white bits on it, the white discs? They look like bass drums. Those are microwave transmitters. If a pigeon made its nest on top of that, its eggs, any eggs that were laid, would be cooked just like in a microwave oven. But as you move further away from your transmitter, the intensity drops off, of course. But how harmful is it? You're going to investigate it. Here's a picture of, I think it's in Washington in America, of what it would look like if you could see Wi-Fi hotspots. So there you can see there's about 4 routers shown in that picture that are spreading out the Wi-Fi over the microwave radiation over that area in front of the White House, if that's what it is. I think it is. And you can see the gaps there. So if you were walking along with your phone, you would drop out of signal, and you can see where that would happen. Yeah, it is the White House. There it is. So here's another picture of what it would look like if we could see the Wi-Fi network, which is a microwave radio signal network, all around the place. So the question is in the document about the general questions about infrared, ultraviolet, and microwaves, but 2 longer answer questions about the ozone hole and about the use of microwave in communications. The silvery apple symbol is cold, and as are my glasses. Infrared won't go through glass. My coat's blue, so that's fairly cold. So there's a question on infrared in the document.